Hello Math Humans, we're going to do G1 today. We're going to be starting our work with quadratic functions. So our objectives are that we're going to manage the characteristics of quadratic functions. So as we get started, our general formula for a quadratic is going to be y is equal to ax squared plus bx plus c. A is called the leading coefficient. If a is greater than 0, meaning that a is positive, then we know that our parabola or quadratic function is going to point up. If a is less than 0 or negative, it means that our parabola is going to go down. Okay? C is going to be the Y-intercept, or as this book calls it, the vertical intercept. Okay, your coordinates for that would be 0, C. If here is a general graph of a parabola, and I'm going to make it off-center a little bit just so it's easier to see. So let's say there's my parabola. This point down here is called the vertex. It is the minimum of the function. Okay, so it is the minimum of the function. So this is called the vertex. Going through the vertex is the axis of symmetry. Okay. The vertex has coordinates h and k, which are going to be an x and a y. Okay. If we go back and talk about a little bit, if a is greater than 1, that means that my parabola is going to be wider. Okay, so maybe my parabola would be something like this if a is greater than 1. And then if a is less than 1, it's going to get narrower or skinnier. And so maybe my parabola would look like that if a was less than 1. Okay, so those would be what happens to the shape as you change the value of a. So we talked about this is my vertex, and it has coordinates h, k, or it is an x and a y. Okay, so this is going to be the notation that we're going to use. And then my axis of symmetry is going to be a vertical line, and it's going to go through the x coordinate of the vertex. So it's going to be x is equal to h. So the axis of symmetry is always drawn as a dashed line. It's not an asymptote, but it is just showing that it is the center of the parabola. If you took the parabola and bent it in half on the axis of symmetry, the two pieces would match up exactly. All right, let's start going through some examples. So the first example, we're going to be given y is equal to 3x squared minus 2x plus 5. So we want to determine a, b, and c, and then we want to find our vertical intercept or the y-intercept. So a is going to be 3, so this is a. B is going to be a negative 2, so this is b. It's always by the variable that has a linear power or a power of 1. And then c is going to equal 5. Okay, and so this would be c. So remember that c is the y-intercept, so my y-intercept is going to be 0, 5. Okay. If we talk about some other characteristics, and I forgot to write it down, but this particular parabola is going to open up. I'm going to write opens up because a is positive. Okay, so that means that my parabola is going to be something like this. Okay, and that's going to be where it crosses the y-axis. It points up because a is positive. And then let's just put that in our calculator so we can see what it looks like. So let me clear all the things I have there. And so if I enter that equation, 3x squared and then minus 2x plus 5 zoom 6, so the standard viewing window, and there you can see our parabola, okay? So we'll talk about why it doesn't cross the x-axis later in the chapter, but that's going to be our starting place. So for example number 2, we're going to be given this equation, a negative x squared plus 7x. I want to do the same thing. I want to find a, b, and c. I want to find my vertical intercept or the y-intercept. I'll write y-intercept. And I want to know, is the parabola pointing up or down? So technically there's a 1 right there. I guess it helps if you can see the equation. So since there's a 1 right there, we know that a is equal to a negative 1. B in this case is going to equal 7. And C in this case, there's nothing here. So C is actually going to equal 0. Well, since C equals 0, that means that my y-intercept is going to be through the origin. Okay. A is negative, so it's less than 0 or negative. So we know that the parabola is going to open down. Okay. We found our y-intercept. We found A, B, and C. And then if I just put this in my calculator to verify, I'm going to put a negative x squared plus 7x soon 6. And then we'll be able to see our parabola. Okay. You can't see the top of the parabola, but at this point, that's okay. Alrighty. So now what we want to do is we want to try to find the coordinates of our vertex. So let's say here is my handy-dandy parabola, and it's going to have a vertex. It's going to be right there at the bottom. And remember we talked about it has coordinates hk. Well, there are some little formulas. I don't know what you officially call them, but that's what I call them. I call them the little formulas, and I know that h is going to equal a negative b over 2a, and k is going to equal the function evaluated at h. Okay, so these are going to help us find our vertex hk, and then remember we also know that the axis of symmetry is going to go through that x coordinate of the vertex, and so it's going to be x is equal to h. So now we're going to do an example where we use these little formulas to help us find the vertex of a parabola. So as we do example number 3, we're going to be given y is equal to a negative 2x squared plus 2x minus 3, and I want to find the vertex and the axis of symmetry using the little formulas. So I'm going to start by rewriting my equation, 2x minus 3, and I'm going to write a is a negative 2, b is a positive 2, and c is a negative 3. Then I'm going to write my little formulas, and I don't know why that's what I call them, but that's what I call them in all of the maths that I teach. H is a negative b over 2a, and k is the function evaluated at h. So let's try to do that math. So h is going to equal a negative, our b is 2, and then divided by 2 times a negative 2, which is going to be a negative 2 over a negative 4, which is 1/2. And I'm going to write that it equals h, and I'm going to put a box around it so I don't lose it. Now I need to find k, and remember that is the function evaluated at 1/2, and so that means it's going to be a negative 2 times 1/2 squared plus 2 times 1/2, and then minus 3. And if I put that in my calculator, so I'll do that, let me clear where we are, and I'm going to have a negative 2 times 1 divided by 2 squared, and then plus 2 times 1/2 minus 3, and then I hit enter, and I'm going to get that k is equal to a negative 2.5. And you need to do it all in one step. So don't do this in tiny little pieces. Your grapher will handle the math doing it all in one fell swoop. Okay? So now I know that k is a negative 2.5. So I know that my vertex is going to be at h and k, and that's going to be 1/2 and a negative 2.5. And I don't mind if you use fractions or decimals, either are okay. And so now we can do our axis of symmetry. And it's going to go through the x-coordinate of the vertex, so that's going to be x is equal to 1/2. So the axis of symmetry is a line, so you have to write as x is equal to 1/2. You can't just write the 1/2. All right, so that wasn't so difficult. So now let's move on and do another example using our little formulas. So in this particular case, we're going to have g of x is equal to, and I'm going to write this as 1/2 x squared minus 3x plus 2. And I want to use my little formulas to find the vertex and the axis of symmetry. So I'm going to write that h is equal to a negative b over 2a, and k is going to equal the function evaluated at h. So if I do my math, a negative b, I'm going to have a negative 3 over 2 times 1/2, because this is a, this is b, and this is c. And so if I do this math, I get a positive 3. 2 times 1/2 is 1, so I get that h is 3. And then I'm going to evaluate the function at 3. So it's going to be 1/2 times 3 squared minus 3 times 3 plus 2. And again, I'm going to do that all in one fell swoop on my calculator. So I'm going to do 1 divided by 2 times 3 squared minus 3 times 3 plus 2. And when I finish, I get a negative 2.5. Okay? So then I know that k is equal to a negative 2.5. So here's my h, and here's my k. So now when I write my vertex, which is hk, that's going to be 3 negative 2.5. We put parentheses because it's a point. And then my axis of symmetry is going to be the equation that goes through the x-coordinate, so it's going to be x is equal to 3. Okay? All right, so that is it for those two. So before we go on to the next example, I just want to talk about quadratic functions in general. So quadratic functions. Okay, so we've deduced that they are a parabola. So if I had a parabola that looks like this, I know that the domain of the function is going to be all real numbers, or negative infinity to positive infinity. The range on this particular parabola, remember range is read from the bottom up, okay, starts at 0, so the range on this one is going to be 0 to positive infinity, okay. And then let's just do another couple of examples of quadratic functions. Let's say my next parabola looks like this, okay, and then this is the point 0, 5. So the domain is going to be all real numbers, or you can write it as the kind of interesting R. My range is going to start at the bottom, negative infinity, and it's going to stop at y is equal to 5, okay? And so it's really not too difficult. And then we'll talk about quadratic functions more as we move along, okay, and talk about other things that we can find out. So we're going to do one more example, and we're going to try to find our h and our k, but we're going to do it a slightly different way. So on this one, I want to find my x-intercept, the y-intercept, and the vertex, okay? So here's my function, so I'm going to write it here. F of x is a negative 2x squared plus 6x plus 3. And so on this particular graph, I'm going to find almost everything using my grapher. So the first thing that I'm going to do, I'm going to put it in my handy-dandy calculator, and I'm going to graph it. So a negative 2x squared plus 6x minus 3, oops, it's plus 3, my bad, plus 3, and I'm going to do a zoom 6, okay? and I'm going to sketch my graph over here on the side. So my parabola looks like this, okay? So as we think about a parabola, we would say that the degree is 2, which means it's going to have 2 x-intercepts. In general, there are cases where it doesn't, but in general, we're going to have 2 x-intercepts. So one of them is here, and one of them is here. So to find that in my calculator, and I'll write down the steps first. So to find your x-intercepts, which are also called the zeros, I'm going to do second calculate 0, and then I'm going to do left, and then right, and then we'll enter. So let's go through that process. So I want to find this one first. So I'm going to do second calculate. I'm going to choose option number 2, which is a 0. And notice that the first question that it's asking me is what's the left. So if my x-intercept is here, I need to be to the left of that point. So there's the left. So I'm going to hit enter. And now it's asking what's the right. And so I'm going to go to the right. So you have to cross the axis. And I'm going to hit enter and enter. And it tells me that that one is at, I can't see it, a negative 0.44. That's that point right there. And then I want to find this one. So I'm going to do second calculate 0. And now the left, so if this is the point, the left is going to be up there. So I'm going to go to the left and hit enter. And then the next question says go to the right. And I'm going to hit enter, enter. And it's showing me that that one is 3.44. So now I'm going to report, so my x-intercept, and it's always reported as an ordered pair, and it's going to be 3.44 and 0. Okay, so those are my x-intercepts, and I found both of them in my calculator. The next thing that I want to find is the vertex. So the vertex is up here. So to find my vertex, when it's turned upside down, this point is a maximum, right? And so that's also my vertex. So to find the vertex when it's a maximum, you're going to do second, calculate, and then maximum, and then left, right, and then enter. Okay, so let's do that math. So my vertex is up here. It's also the maximum, the highest value on the function. So I'm going to do second, calculate. Option number 4 is maximum, and it says left first, so I'm going to go to the left, and I just have to go just past the left, and then I'm going to cross the top and go to the right, enter, enter, and it tells me that it is, the vertex is going to be 1.5 and then 7.5, okay? So I'm going to write that there are the coordinates of my vertex, and so that is the 1.5 and 7.5, and notice that your calculator is telling you both values, both for the x and for the y. So we can actually use our calculators a ton. Alrighty? And then I think that's all of the tasks that they asked us to find. Alright, so I lied. We still need to find the y-intercept. So the y-intercept is right there. And so we can also find the y-intercept in our calculator. So the y-intercept is when x is equal to 0. And so if I want to do this in my calculator, I'm going to do second, calculate, and then I'm going to pick value, and it's asking you to enter the x value, and it will give you the y value. So the x value is going to be 0. So now if I do second calculate one last time, value is number 1, I hit enter, and I want to know what happens when x is equal to 0, because that's going to be my y-intercept, and notice that it tells me that it's 0, 3. So now I can write and report that my y-intercept is going to be 0, 3. So your calculator can do a lot of cool things for you. We just have to remember how to use all of its functions. All right, my dears, that's it for today.